Like I said, we've got 2 hydrogens and 1 oxygen in this formula, and we know that because of the subscripts. Now, in this case, we do not have a coefficient. A coefficient would be the number in front of the formula. So first here, let me label this. The 2 is a subscript and only multiplies the element it comes after. All right, and then we also know that 1 is none. Or none is 1. This is what happens when I record. None is 1 when we're talking about subscripts. All right, now, what if we do have a coefficient? So coefficient is the how much part of things. So subscripts are part of the formula. They tell me what the substance is. If I add a 2 to this oxygen, I make hydrogen peroxide, H2O2. That would be a completely different substance. So when I'm working with chemical equations, I can never mess with the subscripts. That is what the substances are, and usually you're given the substances and then you have to figure out how much you need of the different things. The coefficient is what tells you how much. It comes in front of a formula and it multiplies everything in the formula. So we call this the coefficient. And multiplies entire formula. So what I mean by that then is that I might have 2 hydrogens and 1 oxygen in a single copy of a water molecule, but I have 3 water molecules, so I really have a total of 6 hydrogens and 3 oxygens altogether, if that were a term in a chemical equation. All right, so let's look at some different forms that formulas can be in. All right, so we did a lot of ionic compounds a little earlier in the year, and that would be things like aluminum hydroxide, which I would write like this. I've got the symbol for aluminum, Al, and then our polyatomic ions go in parentheses, and we put how many on the outside. So my subscript then goes on the outside of the parentheses. So in this case, aluminum has no subscript, so that's an implied 1. And my subscript for the OH is 3. This is called hydroxide. And that is going to multiply everything inside the parentheses. So when I ask you to break this apart and just count how much you have of what, because you will need to do that, you are just going to keep everything inside the parentheses together, just like we did before when we worked with ionic compounds. So I'm going to say Al, and if I want to count how many, I'm going to set it equal to its subscript. So that is a 1 in this case. I have 1 copy of Al, and for OH, I have 3 copies of everything inside the parentheses. All right, now we're going to add another layer onto that. So what then if we have a coefficient in front of a formula like that? So for example, I could have 5 copies of, and I'm going to make it a slightly different compound with a few more subscripts. We're going to amp it up a bit and take it up to Al2 and then SO4 3. So this would be the compound aluminum sulfate is how we would say that, but we can just break it down. So if I were counting how many ions of each kind, first thing I always do is list the ions that are in the compound. Al is my metal ion, and the entire SO4 is a polyatomic ion. I copy that entire thing and keep it together, including the subscript that is part of the formula for that polyatomic ion. Now I have to count how many I have of each of those. So I have 2 ALs, right? So that's a 2 here, and 3 of the SO4. All right, I only look at the subscript outside of the parentheses. Then, so yeah, wait, put my 3 here. Now I can use my coefficient. So my coefficient is going to be applied on top of that. It's going to multiply everything in the formula. It says I have 5 copies of aluminum sulfate. So each of these will get multiplied by 5 for a total of 10 aluminum ions and 15 sulfate ions. And those would be my final totals. I usually have people circle the final totals. Not required, it just keeps it clear. All right, so that's what we're going to be doing on this worksheet. This is our foundation skill for learning to read chemical equations and tell if chemical equations are balanced. So here, then, we're going to go down and look at a few examples. So first step is always list the elements. All right, elements are ions. So in this case, I have 1 element. I'm going to write that O is equal to. Second step, set it equal to its subscript. Third step is multiply by coefficients. I don't have coefficients, so this is my total. I have 2 oxygen atoms represented here. All right, now I'm going to skip over to this one. NaCl, I list the elements. That's my first step, list. Second step, set it equal to the subscript. That is right. No subscript means 1. I have no coefficient, so that is my final for each of those. Now the next one is very, very similar, right? But it does have a coefficient, so we'll just be adding on that last step. So Na is 1, Br is 1, but now I'm going to multiply everything by the 2. It applies to the entire formula. So this is times 2, so I have 2 Na total and 2 Br total. Oh, why did I put Br there? I meant 2. There. Like that. Yeah, pretty much. So a few more tricks, but mostly it's easy. Yeah. All right, so this one's straightforward. This one, now this will be the first one where we have a polyatomic ion. I'm going to list the ions first. So I have K, which is potassium, and I write the entire formula for carbonate, everything inside the parentheses. And some people even like to include the parentheses because it just kind of helps them keep that part of it straight and not get confused about what's what. So you can include them, you don't have to, it's up to you. All right, now I'm going to look at the subscripts. So if it's just a regular element symbol, I set it equal to the subscript. If it's a polyatomic, I'm going to look outside to that location outside the parentheses on the right. If there's nothing there, then it's a 1. So I have 2 copies of potassium and 1 copy of carbonate. And that one's done. All right, so let's see. We will go to this one. And in this case, now we're adding in a coefficient with a polyatomic ion, but the process just stays the same. Na, and I'm going to write that entire CrO4 out. That's called chromate, but you don't have to know that. You just copy everything inside those parentheses. Now I'm going to set it equal to the subscript, so I've got a 2 on Na, and I have nothing outside the parentheses for chromate, so I'm going to put a 1 for that one. Okay. All right, 2 and 1. And then I do the coefficient over here, right? Applies to everything, so both of these are times 5. So it's going to be 10 and 5 for this one. Okay. And then the rest of them are pretty much variations on that same theme. Don't let yourself get tricked by this one. It's got 2 polyatomic ions, so in both cases you're going to copy everything inside the parentheses. There's no subscript on the outside, so it's going to be NH4 equal to 1, NO3 equal to 1. And then you multiply by the 3. Okay, so that's it. I think after this I'll just go around the room and check in with people and make sure that you're understanding it. This is turned in as a photo text entry.